Assalamualaikum warahmatullahi wabarakatuh. We are from Group 9, Section 3. Today, we would like to present about population growth and Newton's law of cooling. Our group will discuss about question 9 for both topics. First, I will introduce our team member. Firstly, me, Muhammad Luqman Hakim bin Abdul Aziz, matrix number AA211045. Second, Muhammad Saifuddin bin Ahmad Karohi, matrix number AA211411, and Muhammad Hazim bin Jumali, AA211641. Next, Eddie Amirul Iman bin Eddie Miss Mulyadi, AA210012, Muhammad Faiz Haikal bin Abdullah Sani, AA211338, and Naili Batrisha binti Nasharuddin, AA210943. Now we will discuss about the question. For population, we are given the question number 9, which is the rate of decay of a radioactive substance X is proportional to the mass of the substance remaining. The mass of X is X gram at time t years after decay. Given that t equal to 0, X equal to m. Question A, find X in terms of m, t, and the constants of proportion. Question B, it is known that after 900 years, the mass of the X will have half. Find X in terms of M and T. And question C, how many grams of X will be left after 1000 years? Give your answer in terms of M.
Okay, next for the filler table, we have 4 column of filler table, which is for the first one, we have facts, ideas, learning issues, and resources needed. For the facts, we have 4 facts, which is for the first one, the rate of decay of a radioactive substance is X is proportional to the mass of the substance remaining. Second, the mass of X is X grams at time t years after decay. Third, given that t equal to 0 and X equal to m. Fourth, after 900 years, the mass of the X will be half. Okay, for the second column, which is ideas, we have 2 ideas. For the first one, which is because S is equivalent to the mass of the substance. Second, because mass continue decrease in the following years. Okay, for the third column, we have learning issues. We have 4 learning issues, which is for the first one, calculate X in terms of m, t, and the proportional constant. Second, the mass of X will be half. Find X in terms of m and t. Third, how many grams of X will be left after 1000 years? Okay, fourth, give your answer in terms of m. Okay, for the last column, which is resources needed, we have 4 resources, which is for the first one, internet. Second, in engineering mathematics book. Third, teacher and lecturer. For YouTube. Okay, that's all for the filler table. Okay, thank you.
Assalamualaikum warahmatullahi wabarakatuh. Pada hari ini saya akan menerangkan mengenai solution untuk soalan 9A. Di sini soalan untuk 9A ini dia tanya iaitu find X in term of M, T and the constant of proportion. Maksudnya dia minta jawapan X dalam bentuk M dan T. So dari sini kita boleh menggunakan formula dx over dt equal to negative kx. Kenapa guna dx over dt? Sebab dekat main soalan tu dia dah bagi jisim berkadar dengan masa. So kita akan gunakan dx over dt sama dengan negative kx. So untuk the first untuk jalan kerja yang pertama ialah kita kumpulkan semua X sebelah kiri dan yang selebihnya sebelah kanan. Sebab apa kita kumpulkan X semua sebelah kiri? Sebab soalan minta X in term of M dan T. So kita akan kumpulkan semua X sebelah kiri. Bila kita dah kumpulkan X semua sebelah kiri, kita integratekan kedua-dua belah, iaitu kiri dan kanan. Bila kita integrate, kita akan dapat integrate 1 over X dx sebelah kiri, 1 integrate negative K dt. So bila kita integrate, kita akan dapat ln X sama dengan negatif KT plus C. Tu untuk equation pertama. So dekat soalan utama juga dia dah bagi T equal to 0, X equal to M. So daripada equation yang tadi kita dapat, kita masukkan nilai T dan X tadi, nilai T dan X yang diberi dalam equation tu untuk dapat nilai C. So bila kita dah masukkan nilai dan kita dapat nilai nilai C tu kita masukkan balik dalam equation yang tadi tu, kita akan dapat equation baru. So equation baru tadi itu kita akan dapat ln X sama dengan negatif KT tambah ln M. Kat situ kita akan kumpulkan semua ln di sebelah kiri dan selebihnya di sebelah kanan. Seperti yang kita tahu, property untuk ln ni ada, kita boleh tahu sebab ln X tolak ln M tu kita boleh gabungkan disebabkan property ln.
So for question B, it is known that after 900 years, the mass of the X will have half. Find X in terms of M and T. So first step, we list down all the information that has been provided in the question. In this question, the information is T equal to 900 years and X equal to M over 2. Second step, we calculate. We use the equation X equal to M exponent power of negative KT. Next, we include the value of X and the value of T, which is the equation will be M over 2 equal to M exponent power of negative K 900. We take out the M and the equation will be M multiple with 1 over 2 equal to M exponent power of negative K 900. And the equation will be 1 over 2 equal to M exponent power of negative K negative 900K. So for the last step, we apply log on the both side and find the X. So the equation ln 1 over 2 equal to ln exponent power of negative 900K. From the equation, ln and exponent will be eliminated because they meet each other. So the equation will be ln 1 over 2 equal to negative 900K. Ln 1 over 2 is negative 0.6931 equal to negative 900K. And we include the value of K, which is 7.7 multiple with 10 power of negative 4. And the final answer will be X equal to M exponent power of negative 7.7 multiple with 10 power of negative 4 T. And for question C, how many grams of X will be left after 1000 years? Give your answer in terms of M. So first step is we list down all the information that has been provided, which is T here is 1000 years. Second step, we find the answer in terms of M. We use the formula X equal to M exponent power of negative 7.7 multiple with 10 power of negative 43. The answer from the previous question. So X equal to M exponent power of negative 7.7 multiple with 10 power of negative 4, and we include the value of T, which is 1000. So the equation will be X equal to M multiple with 0.4630, and the final answer is X equal to 0.4630 M.
Hi, my name is Muhammad Hazim. Now I will present about the question 5. The question that my team and I get is question 9, which is topic Newton's law cooling. The question 8 is a detective finds a murder victim at 9 a.m. in a room that is kept constant temperature 20 Celsius. The temperature of the body is measured to be a 32 Celsius. 2 hours later, the temperature of the body cools to 30 Celsius. Assuming the body temperature of the victim when the murder occurred is 37. At what time did the murder occur? Next, I will explain about the Fila table. On the column facts, we get 3 facts, which is: first, a detective find a murder victim at 9 a.m. in a room that is keep constant temperature 20 Celsius. Second, the temperature of the body is decreased from 32 Celsius to 30 Celsius after 2 hours. Number 3, assuming the murder happened when the body is temperature is 37. Next, the ideas what we get is related to the fact. First, the dead body is found on 9 a.m. Second, the body did not generate heat after die. Number 3, normal person is 37 Celsius. Normal person temperature is 37 Celsius. Next, what the learning issues that I get based on the question. So the question 1 is at what time did the murder occur? So we must find the times. So to solve the question, the action plan is: first, do an equation by the information given. Second, compare between the temperature and time. Third, substitute temperature in Celsius to a unit Kelvin. Fourth, solve the equation by using a Newton's law of cooling method. That's all for me. I will pass to the next presenter.
Next, I will explain the solution of this question. First, we use this formula, Newton's law of cooling. So, this question have 2 timelines, which the first timeline we can get the constant. We can get the data, which is temperature room is 20 degrees Celsius, equal to 293 Kelvin. Initial body temperature is 32 degrees Celsius, equal to 305 Kelvin. Time is 2 hours, equal to 7,200 seconds, and temperature final is 30 degrees Celsius, equal to 303 Kelvin. So we insert the data in the formula, and we can get the constant R equal to 2.59 exponent -5. Next, we can find the time that the murder was occurred. The dead body found on 9 a.m. but we don't know the initial time. The data that had given is temperature room is 20 degrees Celsius, equal to 293 Kelvin. Temperature initial of dead body is 37 degrees Celsius, equal to 310 Kelvin, and temperature final is 32 degrees Celsius, equal to 305 Kelvin. So we insert the data in the equation by using the constant equal to 2.59 exponent -5, and we can get the T equal to 13,448.13 second. After that we convert 2 hours and we can get 3.74 hours. 3.74 hours equal to 3 hours and 44 minutes. 9 a.m. minus with 3 hours and 44 minutes, and we can get the time that the murder occurred was at 5:16 a.m. That's it for me. Thank you.
Next, I will conclude this presentation with tell you guys that it is indomitable that problem-based learning, which is PBL engineering mathematics, plays a great role in the 21st century, where it enables students to learn how to solve problems that are important to them. Moreover, it facilitates students to think critically and learn to look at problems with different perspectives and come up with suitable solutions. We are given 2 questions where both the questions are based on the topic about population and Newton's law of cooling. For the first question, we do the calculation about population growth. We find the x grams using the first order differentiation calculation. For the second question, we have the application of Newton's law of cooling. This law is used by Newton's second law to determine the victim's temperature, and it helps us to find out when the murder took place. So that's all from me. Thank you.